Okay, so in this video, we're going to talk about inverses. So I wanted to start off with you just kind of explaining what inverses are. And basically what they are opposite functions. So they're two functions that do the exact opposite of each other. So in this particular instance, my first function is x plus 5, so it adds 5 on, and my second function g of x is x minus 5. So what the idea is, remember that functions are just machines and we're just putting numbers in. So let's say that I put the number 7 into this machine. Well, then that means I'm going to do 7 plus 5 and I'm going to get the number 12 out. Well, then what we're going to do is take that number 12, send it on to the next machine, or the g of x here, and put 12 minus 5, and we're going to end up getting 7 out. So notice that I ended the same way I started, and that's what machines do. And the really cool thing about it is it doesn't matter which machine I start on, as long as I run it through the opposite machine, I'll always come back to whatever number I started. So for instance, if I start with the g of x function and I put the number 15 in, I'm going to put that in here and say, okay, well, 15 minus 5, that's going to give us 10. So we're going to take that 10 and we're going to bring it all the way over here to our f of x function and place that in. And we're going to say 10 plus 5, and we get back to 15. Again, notice I'm matching whatever I put in to the first one and went through both machines, I got back to the original. So that's really what inverses are about. They're finding those opposite machines. So in order to do that, we have a couple steps that we're going to do. So when we're doing this with equations, the first thing we're going to do is we're going to replace the f of x back with y. And it doesn't have to be f of x. It could be any letter, v of x, p of x, h of x, just whatever the of x is, we're going to replace with y. Then the second thing we're going to do is we are going to switch x and y. Literally just switch them around in the equation. Wherever we see an x, we're going to place y. Wherever we see a y, we're going to replace it with an x. And then the third thing we're going to do here is we're going to solve the equation for y. Okay, and this is actually, this step right here is the most important, as well as the one that's going to actually find our inverse for us, is solving for y. It is actually the most intense part of the whole process, is that third step. And then the fourth step is once we solved it for y, we're going to replace the y with f to the -1 of x. Now you might be saying, why are we putting -1? All that -1 is doing for us is indicating that this is the inverse, and we always want to make sure that whatever number or letter sits here, it's the same letter here. Again, I'm using f because that's our most common thing, but if my function was h of x, then when I find my inverse, it's going to be h to the -1 of x. And again, all this -1 does up here is that just indicates that it's an inverse. Okay, so now let's do a couple of examples. So I picked some out of Hawks for you guys. So number one, we're going to find the inverse of f of x equal to 2 over x plus 1. Okay, so again, working through this, the first thing we're going to do is take this f of x and we're going to switch it with y. So y equals 2 over x plus 1. So the next thing we're going to do is we're going to take this y and this x and literally switch them around. So now we're going to have that x equals 2 over y plus 1. All right, so that's step 1, switching our f of x to y. Step 2, switching our x's and y's. And then, like I said, the third step is always going to be the hardest. We're going to solve for y. Now, one thing I want to remember is anytime we're working with a fraction, the first thing we're going to want to do is multiply both sides by that fraction. Okay, over here on the right-hand side, the y plus 1s are going to cancel each other out. That's why we did it. Over here on the left-hand side, we're going to distribute this x So we get x times y plus x, and this is now going to equal 2. And again, remember, this whole thing is all about solving for this y. So in order to get the y by itself, we're going to move this positive x first. So we're just going to subtract x from both sides. So this guy goes away. And then we have xy equals 2 minus x. And if you don't like the x being behind the 2, you can put the x in front of the 2. It really doesn't matter. I just tend to stick it at the end. It makes it easier in the long run. And then the next thing we're going to do is we're going to get rid of that x in front. Remember that this is multiplication. It's x times y. So the opposite is to divide. Do a big division over here on the right hand side. So our x's go away. And we get y equals 2 minus x over x. And again, we've solved for y, so that was our step 3. Now we're going to take this y and we're going to replace it with our f of x, but it's going to have that -1 to indicate it's an inverse. So f -1 of x equals 2 minus x over x, and this would be our answer for this first example. Okay, and I know it doesn't look like it, but those are actually opposite functions. So if I were to plug in the number 1 to this one, figure out what the answer would be, and then plug that answer back into the original equation, I would get back to the number 1. So it's really kind of a cool little process. All right, so let's do another example. So let's do r of x is equal to x minus 7 divided by 8. So again, starting off, replacing this r of x with y. So y equals x minus 7 over 8. Taking the x and y and just switching them around. So x equals y minus 7 over 8. Again, just like the previous one, if I have a denominator in my problem, the first thing we want to do is multiply by that denominator just so we can get it out of the way. So we're going to multiply by 8 on both sides. So over on the right, those 8's go away. So we have 8x equals y minus 7. So remember, our whole goal is to solve for this y here. So we want to move that 7. So we're going to add 7 to both sides. And we're going to get that 8x plus 7 is equal to y. And we're actually done. We've solved for y. So again, remember, we're going to replace this y with our function. Remember that our function had a letter r in front of it. So when we do our replacement here, we're going to do r little -1 of x is equal to 8x plus 7. And this would be our answer for this problem. Okay, I've got one more fraction one to do. It's probably the hardest one of all of the problems. So it's number 3 here. We have h of x is equal to -x minus 2 over -2x plus 3. Again, remember taking that h of x and making it a y. So y equals -x minus 2 over -2x plus 3. Now when we switch this, this is going to become, that y is going to become x, and both of these x's are now going to be y's. Okay, so when we do switch and we have multiple x's in our problem, we'll never have multiple y's, but we can have multiple x's. Every single x becomes a y. So now this becomes x equals -y minus 2 over -2y plus 3. Okay, so now to solve this, again, we've got a denominator, so we've got a bottom of a fraction. We want to get rid of that by multiplying by -2y plus 3 on both sides, just like we've done on the very first problem and kind of what we did on the last one. We just had that number 8. So now we're going to distribute this x to both of those terms on the left-hand side. And we are going to get -2xy plus 3x. And then our -2y plus 3's are going to cancel, leaving -y minus 2. Now you'll notice that in this one we have multiple y variables. So what we're going to have to do is we're going to have to move all of the y's to one side, preferably the left-hand side, although it really doesn't matter. And then we're going to move everything else that doesn't have a y over to the other side. So that means that this negative y needs to go this direction, and this positive 3x needs to go that direction. You can do this one piece at a time, or you can do them both at the same time. That's up to you. I'm going to go ahead and move the 3x first, and I'm going to do this one piece at a time. I'm going to subtract that 3x. I'm just going to put him at the end here. So now we have negative 2xy equals negative y minus 2 minus 3x. Now we're going to move that y. Since he's a minus y, we're going to add him to both sides. Now, remember, you can't actually add the negative 2xy and the y, because even though they have y's, they're not like terms. Remember, like terms, they have to have the exact same variables. And so since the 2xy has the x and the other one doesn't have an x, you can't actually combine them. So we just end up with negative 2xy plus y equals negative 2x, oh, not x, sorry about that. How about negative 2 minus 3x? There we go. All right, we're almost done, guys. We're getting really close here. So what we're going to do is, you see how each one of these terms has that y variable? We're going to do a GCF. We're going to factor out the greatest common factor, which happens to be y. We're going to put that y out here in the front. And basically what you're going to do is cross out the y's here and ask yourself what's left over. So left over from the first one would be negative 2x. Plus, and what I need you to understand is anytime you have a variable, remember there's always the number 1 in front of it. So if we lose the y, we still have the 1. So this would be plus 1 equal to negative 2x minus, oops, I did it again, guys. Sorry about that. I don't know why I want to put an x on that. How about negative 2 minus 3x? Almost done. Remember that this is now multiplication, so we're multiplying y times this entire parentheses. So what we're going to do is we're going to use our opposite operation, which is division, and we're just going to divide by everything in that parentheses on both sides. So negative 2x plus 1 on both sides. These guys go away. And y is equal to negative 2 minus 3x over negative 2x plus 1. And then again, we're going to switch to this y back into our function notation. I'm going to kind of scroll back up real quick. I don't remember what letter we started off with. Oh, it was an h. So we're going to do h inverse of x is equal to negative 2 minus 3x over negative 2x plus 1. And this would be our answer right here for this one. In my opinion, this is probably the hardest problem in your homework with the two variables and the fraction, because you have to do quite a bit of work to get the y by itself. But that's just my opinion. So now we're going to look at a couple different problems where we have some powers and some roots going on. So our first example with powers and roots is going to be k of x is equal to 4x plus 2 to the 1/3. Now, if you don't like the fact that this is a fraction with this 1/3, you can rewrite this if you want to. It is up to you. You could say that this is k of x, and then this little 3 right here in the denominator is your root. So this in this particular problem is a cube root, and this 1 on the top is your power. So in this case, the power would be 1, which we wouldn't really care about because raising something to the first power doesn't actually change anything. So we could rewrite this guy as the cube root of 4x plus 2. It's up to you how you want to work this problem. It doesn't really matter. You can do either one. The biggest thing you want to have to remember is that if it is a fraction like this with the 1/3, that is a root. Therefore, the opposite operation of a root is always a power. and it's the power of whatever the root is. So since this is a cube root or a third root, then the opposite of a third root would be a third power. So that's all you kind of really have to remember when you're doing these. Now again, I'm going to start off with my first step, which is to take that k of x, change him to a y. I'm going to go ahead and keep it as that 1/3. Again, if you don't like that, you can change it over to a root. Okay, so now we're going to switch our y and our x here. So we're going to have x equals 4y plus 2, still raising that to the 1/3. Again, remember the 1/3 is like a cube root. So the opposite of that is to raise this guy to a power. So we're going to raise everything to the third power, which means we're also going to raise the x to the third power as well. The 1/3 and the 3 cancel each other out. So we get x to the third equals 4y plus 2. Again, remember, this is all about getting this y by itself. So the next thing we're going to do is go ahead and subtract 2 from both sides. So we have x to the third minus 2, oops, going ahead of myself there for a second, equals 4y. And then to get rid of that 4, we're just going to divide everybody by 4 again, making sure we do that entire left-hand side divided by 4. So we have x to the third minus 2 all over 4 is equal to y. And then again, we're going to change this back over into function notation. If you remember, the letter we used in this one was k. So we're going to have k to the -1 of x. And it's going to equal x cubed minus 2 all over 4. And this would be our answer here. Okay, so the next one I want to do kind of looks a lot like this one, but my root is actually in a different location. I want to talk about the difference. On this one, when you're looking at it, notice that the 4x plus 2 is all in parentheses to the power of 1/3. So in order to get to the 4x plus 2, we had to get, or the 4y plus 2, I should say, we had to get rid of the 1/3 first. But on the next problem that we're going to do here, number 5, we've got v of x is equal to 3 times the 5th root of x minus 4. Now, notice on this one, the 3 and the 4 are actually outside of that 5th root. So we'll actually, when we're solving for y here in a second, we'll actually move the 3 and the minus 4 first, and then the last thing we'll do will actually be with the 5th root. But again, before we start that, we got to switch our y and our x. So we're going to replace that v of x with y. And then we're going to switch these guys around. So x equals 3 times the 5th root of y minus 4. So remember, when you're moving stuff around and it's outside of your radical or outside of your root, you want to always do your addition subtraction first. So in this case, that means we're going to add that 4 to both sides before we try to get rid of the 3. So x plus 4 is equal to 3 times the 5th root of y. Then we're going to divide everybody by 3. Again, we got to get the root by itself first before we can do the opposite of it. So now we're going to have x plus 4 over 3, and that's going to equal to the 5th root of y. And then the next thing we're going to do is we're just going to raise this entire thing to the power of 5. Again, the reason we're using the power of 5 is because I always want my root and my exponent to match each other here. That way they cancel each other out and leave just the variable underneath here in this case, which would be our y. Now, notice that when I raise the other side, the left-hand side to y, I did a really large parentheses because that entire fraction, x plus 4 over 3, gets to be raised to the 5th power. And you don't actually have to do anything. You can leave it in this fraction with the power on the outside. That's perfectly acceptable. Again, all we're going to do next is take this y, change it back into function notation. We use the letter v on this one, so we'll have v to the -1 of x equal to x plus 4 over 3 raised to the 5th power. All right. So the last one I'm going to have us do for today is this 6th one, where we're going to have both a power and a root in it. So we're going to have p of x equal to x cubed plus 1 raised to the 1/5 power plus 2. Okay, again, always starting off with our first step of changing our p of x, or whatever our of x is, to y. So y equals x cubed plus 1 raised to the 1/5 plus 2. Again, taking our y and our x here and switching them around. So we have x equals y cubed plus 1 raised to the 1/5 plus 2. Now I know we want to get rid of the 1/5, or the root of 5 here, but in order to get the root of 5, we have to get rid of the plus 2 first. Remember, you always want to get rid of the stuff on the outside of your parentheses, things that are added or multiplied outside of the parentheses or outside of the root, before you can address either the power or the root. So we're going to go ahead and subtract 2 from both sides. So x minus 2 is equal to y cubed plus 1 raised to the 1/5. Again, remember that this isn't really a power, it's a root, because it is a fraction 1/5. So in order to get rid of this, we're going to raise it to the 5th power. If you want to think about it, it's always going to be the opposite. So since this is 1/5, you're basically flipping the fraction over to 5/1. That way they cancel each other out. We just don't need the over 1 here. So we're going to raise this guy to the 5th power. So now we have x minus 2 to the 5th power. And these guys are going to go away. So we're going to have y cubed plus 1. Notice I dropped my parentheses on the right-hand side. Since we got rid of that 1/5, we don't need the parentheses anymore. So the next thing we're going to do, because we are still trying to isolate my y here, so we're going to move that plus 1. So let's subtract 1. Now when you do this, this is going to go behind my parentheses. I can't actually subtract the 1 and the 2 because the 2 is inside the parentheses. So it's kind of isolated there, and we're going to put the -1 on the outside of it. So we're going to do x minus 2 to the 5th power minus 1 equals y to the 3rd. So now we want to get rid of this 3, power of 3 on the y. So the opposite of a power is always the root. So the root of whatever the power is, since this is a cube or a 3rd root, then the opposite is a cube root or a 3rd root, however you want to say that. I like to just do the root sign with my little 3 here in the V. But if you wanted to, you could also raise this to the 1/3 power, kind of doing that opposite, because if, again, you think that's 3/1, so you can do the opposite, which would be 1/3. I just like the way cube roots look. Make sure when you do the cube root on the left-hand side, you do the entire left-hand side underneath the root. Make sure you put your 3 in the little V there. So over here on our right, our cube root and our cube cancel each other out. So we're going to have the cube root of x minus 2 to the 5th power minus 1. That's going to equal y. Again, to finish this off, instead of having a y here, we're going to change it back to our function. Remember, our letter was p, so we're going to do p -1 of x equals the cube root of x squared, or x minus 2 to the 5th power minus 1, and this would be our answer for this problem. If you need any additional examples, just let me know.